All right, y'all be good and well behaved for the substitute today. Okay. Today we're going to do part of 8.2, similar polygons. A dilation is a type of similarity transformation. A similarity transformation is a transformation composed of a dilation or a dilation and a rigid transformation. Two figures are similar polygons if one can be obtained from the other by a dilation or a dilation with one or more rigid transformations. Triangle ABC can be mapped onto triangle DEF with two rigid transformations and a dilation with a scale factor of K. So here, triangle ABC is similar to DEF. Okay, similar to DEF. When two triangles are similar, their angles and sides are related. The angles will be the same. The corresponding sides will be proportional. So, two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional, like I just said. So, here, the key is when we look at the similarity given. So if you look at the symbols right here, angle A is going to be congruent to angle W. Angle B is going to be congruent to angle X. Angle C is going to be congruent to angle Y. And angle D is going to be congruent to angle Z. You don't even need to look at the picture. Okay. Same works for the corresponding sides. AB is going to be corresponding to WX. BC is going to be corresponding to XY. And then we got CD will be corresponding to YZ. And then last AD would be corresponding to WZ. So we'll keep going over that as we go. You don't even need the picture. Sometimes they try and trick you with the picture. So, reflexive property of similarity. Triangle ABC is similar to triangle ABC. That's what that squiggly line is, similar. Symmetric property. If triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. Then we have the transitive property. If triangle ABC is similar to DEF and DEF is similar to XYZ, then ABC is similar to triangle XYZ. So, example 1 right here. It gives you a little chart right here to try and show you what I was just explaining. When you're looking at the angles, okay, A is going to be congruent to P. First and first. B is going to be congruent to Q. C is congruent to R. D is congruent to S. Okay. The order of the similarity statement matters. Okay. So you need to look at that. Then the proportions, same thing. AB, the first two, is proportional to PQ. BC, QR. CD, RS, and then last AD and PS. Okay, so you don't even need the pictures. Again, they try and trick you with the pictures. So if we look at this check, all right, if you want to pause it right now, go ahead and pause it, and then go ahead and do the check, and then turn it back on to check your answers. Okay, well, if you paused it and unpaused it, angle N is congruent to angle U. P is congruent to angle V. Q congruent to angle S. R congruent to angle T. And then we're looking for proportions from the sides. NP is congruent or is proportional to UV. PQ and VS. QR and ST. And then NR and UT. Okay. So, angles are congruent, sides are proportional. Example 2 right here, we're going to determine whether the triangles are similar. If so, find the scale factor and explain your reasoning. So first, we need to compare the corresponding angles. Well, because N is congruent to R and Q is congruent to S, by the third angles theorem, P is going to be congruent to T. So the angles are congruent. So next they compared the corresponding sides. So they took NQ over RS, the proportion simplifies to 5/4. QP over ST simplifies to 5/4. PN over TR, sorry, I should underline that for you. You got that, and then third, we got PN over TR simplifies to 5/4. So because the corresponding angles are congruent and the corresponding sides are proportional, those two triangles are similar. So the triangles are similar with a scale factor of 5/4. Okay. So if you want to do the check here again by yourself, go ahead and hit pause now. All right. Well, as you can see, all four angles of each quadrilateral would be right angles. So the angles are congruent, so we're good there. So we need to look at the corresponding sides. So we have CD is going to be corresponding with HG. So first, I did 10 over 14, and I simplified that to get 5/7. Okay. So next, I'm doing BC over FG. So I got 8 over 12. It's important that you keep that same order. Okay. If you did A, B, C, D first, or on the numerator, in the first one, A, B, C, D needs to be in the numerator on the second proportion. So then 8 over 12 simplifies to 2/3. So no, the corresponding angles are congruent, but the corresponding sides are not proportional. So that means that they are not similar quadrilaterals. Okay? All right. So next part here. We're using SimFigs to find missing measures. That was pretty cool. I said SimFigs, right? Similar figures. All right, so here in the diagram, we have WXYZ is similar to PQRS. Find the value of Y. Well, you need to use two sets of proportions and set them equal to each other. So they set it up as WZ over PS. Okay. WZ, if you notice on the similar, WZ over PS, they match up. And then they did YZ over RS. Okay. So that was 16 over 12 equals 5Y minus 2 over 6. So you notice the figure to the left, both those numbers are in the numerator. Figure on the right, the 6 and the 12 are in the denominator, matched up with their corresponding side. Okay. So from there, we're just multiplying and solving for Y. We need to multiply by 6 to get rid of 6 in the denominator, which gives you 16 times 6 on the left side. And then you need to multiply both sides by 12 to get rid of the 12 in the denominator. That leaves you with the 12 on the right side. So you need to do 16 times 6, which is 96. Then distribute the 12, which gives you 60Y minus 24. Then from there, we'll add 24 to the left side, which gives you 120 equals 6Y. Divide by 60, which gives you Y equals 2. Okay. So here, the check. Again, pause it if you want to try and do it by yourself and then hit play. Ain't no shame in your game if you try and do it yourself. So Here, when I set up my proportion, I set it up as Jm, which is 4, over Qt, which is 2, equals. Then I did Lm, which is 6x minus 3, still in the numerator, over St, which is 3. I had to do St because it's corresponding with Lm, okay? The 5 is corresponding with JL, which would have gotten you nowhere. So here, I'm going to go ahead and simplify 4 over 2 to make it 2 equals 6x minus 3 over 3. Then I'm going to multiply by 3 to get 6 equals 6x minus 3. Add 3. I get 9 equals 6x. Divide by 6, and I get x equals 1.5. Okay? All right, so now skip over those next parts and go ahead and go to the practice in your book, okay? If you look at example 1, we need to list all the congruent angles. I'm going to get you started on these. You need to finish example 1 section, okay? So here, I don't even need to look at the picture, okay? Doesn't matter to me. I've got A is congruent to W, B is congruent to X, C is congruent to Y, and D is congruent to Z. All those angles are congruent. Don't even need to look at the picture. You just need to look at the similarity statement. Okay. Next part, I'm listing the proportion of the corresponding sides. So again, I don't need the picture. I've got AB over WX. I've got BC over XY. I've got CD over YZ. And I've got AD over WZ. Okay. Fairly simple there. Okay. Fairly simple. Don't even need the picture. All they're going to try and do is trick you with that picture. All right. Sorry for this may be an awkward reason. My son walked in. Sorry. Number 3 here. Jump through these pretty quick. Super easy right here. No, W is not congruent with L. The angles have to be congruent. So if you look at that, I mean, pretty obvious. W is 39, L is 48. You got M is 42, Y is 51. Those angles are not congruent. So those triangles are not similar. You look at 4. This one, again, it didn't really go over in the notes, but some of you should be able to get 4 kind of easy. Gives you those 2 angles are congruent and those 2 sides are congruent. Well, then XZ is congruent to XZ by the reflexive property. So because of side, angle, side, yes. I mean, those triangles are both similar and congruent. Okay. All right. Y'all go ahead and finish 5 and 6. Now, if you look at 7, okay, the key here, you really need to look at these angles to get your proportions correct, okay? So, seeing W and S are congruent with the right angles and J and R are congruent, I'm going to do X plus 1 over 8 equals 3X plus 1 over 20, okay? So as you can see, I kept the left polygon in the numerator and the right polygon in the denominator. So from there, I multiplied by 20, which gives me 20 times x plus 1 equals. Then I multiplied by 8, which gave me 3x plus 1 times 8. I distributed, which gave me 20x plus 20 equals 24x plus 8. Solving for x. Subtract 20x gives you 4x. Subtract 8, get 12. Divide by 4, and we get 3 there, okay? So go ahead and finish this example 3 section, okay? Finish example 1 section, example 2 section, example 3 section. We will go over them when I am at class on Thursday. I appreciate y'all being well behaved and nice to the substitute, okay? If you finish this video, go ahead and email me to my Okaloosa email a thumbs up, and I will give you credit for completing this assignment. I appreciate y'all, and I will see you Thursday.